Hello everyone, this is Chris Weaver in your physical science class, and today I'm going to talk about how to get the chemical formula from different compounds. So this first one, carbon tetrafluoride. The way you do it is first find the symbol for carbon, then find the symbol for fluoride. That's just looking these up on the periodic table. The symbol for carbon is C. The symbol for fluorine is F. And this is covalently bonded because we have that. We have a prefix, which, remember, you have this table of prefixes. So how many carbons are there? If there's no prefix in the front of this, that means that this was monocarbon. But remember from previously, we don't write mono in front of the first word. We only write mono in front of the second one if it's needed. So there's only one carbon in this. The tetra in front of fluoride means that there are 4 fluorines, tetra being 4. Now let's try C, calcium chloride. Notice there's not a prefix in either of these. So, this is ionically bonded. First, find the symbols for calcium and chlorine. Calcium is Ca, chlorine is Cl. But the next thing we're going to have to do is get the charges. Because unlike with the molecules, unlike with the covalently bonded materials, where the name tells you how many of each element there are, the ionically bonded materials will not have those prefixes to tell you. So we have to look up the charges. The charge for calcium, since it's in the second column on the right, is 2+. The charge of chlorine is 1-. Remember, this row has no charge, and then going this way, 1-, 2-, 3-. So the charge for chlorine is 1-. Now, if I look at these, their charges do not balance. I have 2 positive charges and only 1 negative charge. I need for this to balance out. Well, for this to balance out, I need 2 chlorines. Each of these chlorines will have a -1 charge. 2 times a -1 is a -2. And -2 balances out to positive. Another way I can do this is through what is called the switch method. We simply take this 2 without the sign and move it over here. Then we take this 1 and, well, we don't move it because we don't write 1s down here. Notice on these previous problems, CCl, well, no, let me do this one. NaCl, they don't write 1 after Na and 1 after Cl because it's assumed that if there's no number behind them, there's just the 1 of each. So, we don't move the 1, we just assume the 1 is there. Let's try another one. Let's try magnesium oxide. The symbol for magnesium is Mg, and the symbol for oxygen is O. The charge for magnesium is 2+. The charge for oxygen is 2-. And we're not going to do anything here. These are already balanced. That has 2+, that has 2-. We don't need to change the number of each one, simply because there's as many positive charges as there are negative charges. So this just stays MgO. Let's try calcium phosphate. The symbol for calcium is Ca. Phosphate, on the other hand, is a polyatomic ion. So we need to come over here to this chart and find the symbol for phosphate, which is PO4. Now, looking at the periodic table, calcium has a charge of 2+. And phosphate has a charge, according to our polyatomic ion chart, of 3-. Now we're going to do the switcheroo. We're going to take this 3 and put it over here without the sign. And we're going to take this 2, but we need to do one thing. We need to put that in parentheses, because this is going to double all of that. But I'm going to take this 2 and put it over here. So I move the 3 over here, the 2 over here. Notice what that does. 3 times 2+ is 6+. 2 times, that was a 3. 2 times 3- is 6-. 6+ and 6- are balanced. One more. Let's do iron nitrate. But in this case, it's iron 3 nitrate. What does the 3 tell us? That's the charge of the iron. We had to be told that because iron's in this section where there are several elements that have more than one oxidation number or more than one possible charge. So we have this stock number to tell us which charge that is. Now we need to look up nitrate, and here it is. It is NO3 with a -1 charge. I'm going to go ahead and put that NO3 in parentheses, because I can already tell that I'm going to have to do the switch. The 1 would go here, but we don't write 1s down at the bottom. The 3 goes here, and so now I have 3+ on this left-hand side, and over here I have 3 times a -1, that's 3- on the right-hand side. 3+ and 3- balance out.